Yeah, full disclosure, I did not actually count the steps. There's quite a few of them. I also want to put the word out there that if you found grade 11 nomenclature really kind of weird, sometimes we did ick, us endings on metals, and we use Latin names, and sometimes we use prefixes, and sometimes we call them acids. We're not going to have to deal with all of that stuff in this one. So it feels like there's a lot more steps. And we're only talking about alkanes, but it's going to be much, much more systematic, and it's going to be the same system every single time. As we go from alkanes to alkenes to aldehydes to ketones, we're going to keep a lot of the same stuff in place. Okay, job one. Longest continuous carbon chain is the root name. So every carbon chain, every root name is going to have two parts to it. One is a carbon count, and the other is a functional group part. It might not always work out that way, but all these you see for all the alkanes, they all end in ane. Methane, ethane, propane, and so on. And the first part of the name is the carbon count. So one carbon is going to be meth. With two carbons, I know. Two carbons is eth, three carbons is prop, four carbons is bute, and so on. Once we move on to other functional groups, we still will be counting longest continuous carbon chain. So the carbon count part of the name will stay the same. So if it's a 5-carbon aldehyde, we'll still see pent. If it's a 6-carbon alcohol, we'll still see hex. Too easy. Okay, so I'm going to give you a few. I want you to pause it. I want you to identify the root name, and then we'll come back to it. These ones. Please pause. Okay, so after you paused, you should have ended up with 7 carbons on the first one, 7 carbons on the second one, and again, I'm looking for the longest continuous carbon chain, so it might take a turn here or there. I don't normally do that on purpose, but sometimes. And the last one is 9 carbons in the chain. Now, for each one of those things, or for the two of them anyway, not only did you have a long chain, you also had things hanging off the chain. Well, that's our next job. We want to give those branches, those groups, numbers, position numbers. So we're not counting how many groups there are, but we're counting where they are. So while you went through counting those carbons, you either went from the left or from the right. So here I've got a chain that's 2, 4, 6 carbons long, and I've got 3 branches on that chain. Okay, how do I number it? If I numbered it from the left to the right, then I would have groups at carbons number 2, carbon number 4, and carbon number 5. Not bad. If I numbered it, however, from the right to the left, I would have carbons, groupings rather, at carbons number 2, 3, and 5. And because 2, 4, 5 is a higher set of numbers than 2, 3, 5, I want to number this one from the right, so from right to left. Okay. If I looked at this one, then my groupings would be 2, 2, 4, 6. And if I went from the other direction, if I went from right to left, they would be at 2, 4, 6, 6. Well, 2, 2, 4, 6 is a smaller overall grouping of numbers than 2, 4, 6, 6. So I would number this particular chain from the left to right. So the carbon on the far left would be carbon number 1. Carbon on the far right would be carbon number 7. I would like you to take a look at these examples and decide for yourself how they should be numbered. Please pause while you do this. I'm hoping you paused. Okay, at the end of it, you should have ended up taking the orange one from left to right, the green one from right to left, and the purple one also from right to left. Next step, so we're up to 3, okay. The side chains are going to get a position number and a name. So we need to know what kind of group it is, and we need to know where it is. So, like before, if it's a 1 carbon, meth, 2 carbon, eth, and so on. Yeah, you can have 4 and 5 and 6 and so on, but they're pretty unusual. We do run into a bit of a problem with 3, because with 3 carbons, I have got 3 places where I can attach that chain. And what I mean by on the end and in the middle is if I look at this random chain with 2 groups, both of those groups have the same number of carbons, 3. They have actually the same number of hydrogens if you were to count them up, but one is attached on one of the end carbons, so it's 3 carbons in a row, whereas the other one is more of a V shape because it's the middle carbon of 3 that's attached to the chain. So I still identify them both as a prop, because they're both 3 carbons, but one of them is an isomer of the other. So the one where it's attached in the middle I call isopropyl. Full disclosure, you're going to see isopropyl far more often than you're going to see regular propyl. And the reason for that is with the regular propyl, that's now 3 carbons. I need a really long chain before that 3 carbon group will not be part of the longest chain. Please pay attention to the isopropyl for another reason, because it starts to look kind of like, depending on how it's drawn, it can look a little bit like an ethyl group with a methyl group. You will never get a group in a group. So if you ever see something that looks like it's a group in a group, look at it differently. It's probably an isopropyl, but it might be something else as well. And if it is something else, then you need to look at it again, because I would not give a group in a group. And isopropyl is the only branching thing that we're going to have to worry about. We are going to add more later, not necessarily more carbon groups, although every once in a while you might see something pop up. But particularly things like chlorines and fluorines and bromines are alkyl halides. Okay. Now, when we get to the eventual name, we're going to list groups by their alphabetical order. So ethyl would come before methyl, and that would come before propyl. Isopropyl, we go by the I, so it would actually be in the order of ethyl, isopropyl, methyl, propyl, in those orders. But then we'd have other ones as well, probably. Okay, so I'm going to give you a few to try. I want you to pause it. Once I get this loaded up, there we go. I want you to identify the side chains. Please pause and do that. Okay, I'm hoping you paused it. Oops, oh, there we are. I needed the space. Okay, so at carbon number 3 we had an ethyl, at carbon number 2 we have a methyl. Doesn't matter to me if you had the 2 methyl first, but I've got it leading up to the alphabetical order. This one, you would have at carbon number 3 and at carbon number 5 a methyl. So we would identify as 3-methyl, 5-methyl. However, we're going to do something slightly different before we get to the final name. And on the purple one, 4-ethyl, 2-methyl, 5-methyl. Okay, so far so good. One more step. We are going to, in some cases, have priority groups. And what that means is if there's a group that will change the functional group, okay, so like I said earlier, chloro or chlorine or bromines, things like that, that turns the compound into an alkyl halide. If there's a double bond, we're going to have to do that because now that's an alkene. Now we're not going to deal with double bonds when we're talking about alkanes, but we might have alkyl halides. So those are now the group names for those branches, not fluoro, chloro, bromo, iodo, and they would follow the same alphabetical patterns before. So now bromo would be your first group, and followed by chloro, and so on. You can figure out the alphabet. That priority group must have the lowest number. So even if there's more stuff going on the left-hand side, this structure would be numbered from the right, so that the chlorine group gets, oops, I'm going to go back to that, the chlorine group gets a lower number. So it doesn't matter how much stuff is happening over on the left, chlorine group trumps everything else. A few steps, sort of to put it all together things, and then really that is the last step. If you have a number followed by a word, so a position followed by the type, if there's a dash. If you have 2 numbers, they're going to be separated by a comma, and then we can put those multiple groups together. So from before, this would be 3-ethyl-2-methyl. Too easy. If I had similar groups, I can dump them together and now have both numbers at the same time as a comma. So dimethyl. Now the di does not influence the alphabetical order because it's alphabetical by the group name. So putting it all together, we'll do this one together. 3-ethyl, 2-methyl, hexane. This one, please pause it and try and work it out on your own. We've put all the pieces together. Now we just have to get it finalized. It would be 3,5-dimethyl octane. And again, please pause this one, put those pieces together, and you should have ended up with 4-ethyl, 2,5-dimethyl heptane. when I mark nomenclature questions, there's sort of big mistakes and small mistakes. Not that you're going to make any of them, but the dashes and the commas, for right now, we'll file those under small things. Direction of numbering, root name, and the identifying the groups. Those are the big things. So at this point, what should we be able to do? Well, after a bit of practice, we should be able to name alkanes, and then we'll take this as our starting point for all the other functional groups, and you should be able to draw the structures. Now, I know we didn't do any drawing structures, but it's basically just all of the same stuff, kind of in the same order once you have the name. But we'll practice that a lot in class.